Hello friends, welcome to datamaking.com. In this video we are going to see the overview of Apache Spark. Agenda for the Apache Spark introduction is: what is Apache Spark? Spark framework and its ecosystem, and next we are going to see what is RDD, which is the main abstraction in the Apache Spark. Then we are going to see working with RDD, what all we can do with RDDs. Then we are going to compare we are going to compare Hadoop with the Apache Spark. Then we are going to see some of the Spark use cases. What is Spark? Spark is, as per Apache definition, Spark is a fast and general engine for large data processing. The Spark is a framework which provides in-memory distributed data processing. In-memory means you can do all the computation on memory, means RAM. It is also open source framework developed by University of California, Berkeley. This Apache Spark framework is written in Scala, which is a functional programming language that can run on JVM. Spark also offering simple APIs in the form of Python and Java and Scala and SQL. Okay, so you can write a Spark programs using Python, Java and Scala. So these are the Spark framework Spark ecosystem components. So the bottom one is the Apache Spark. It's a core API which contains core APIs. It's an execution engine. Okay, so it's a you can say it's an alternative to MapReduce. Okay, so it is Spark also another processing framework, okay, which can talk to different data sources, okay, like HDFS, HBase, Kafka, Elasticsearch, Cassandra and S3. So S3 is the another distributed file system. Cassandra, HBase are the NoSQL databases. Kafka is a distributed messaging system which works like PubSub model, and Elasticsearch is a searching engine like Solar. Okay, and above the Apache Spark core API we have some of the libraries which can do different application processing, like Spark SQL is the one of the library where you can write SQL query like syntax and do process, and another application or library is the Spark streaming, where you can do real-time processing, stream processing. Okay, and the third one is the MLlib, which is a machine learning library which a set of machine learning algorithms can be implemented using MLlib. GraphX is the another library for distributed graph based algorithms. So let me describe you each component, what it is, what it can do for us. The Spark core API, it's contains a set of operators so that you can do computation. Okay, so in the Spark, as mentioned in the agenda slide, we have one abstraction called RDD, Distributed Resilient Dataset. We'll see more about RDD in the coming slides. Okay, the next component of the library is called Spark SQL. It's a package to work with structured data, so it can access data from NoSQL databases and some of the structured file formats like text file, JSON files, and a percute file also. It provides a standard connectivity like JDBC and ODBC. The next library is called Spark Streaming, which is used to process live streams. So generally Spark Streaming is micro batch processing model, meaning you can set the interval of your stream data, and within that interval you can whatever the data is coming, that data we can process it. Okay, so you can integrate with HDFS, Flume, Kafka. And the third library is machine learning library. It has a set of machine learning algorithms, so you can explore using machine learning algorithms using this library. It gives you 100 times faster than MapReduce, because it loads your data into memory and runs your machine learning algorithm on the data in memory, so it gives 100% 100 times faster than the MapReduce. So in the coming slide we'll compare MapReduce with Spark. The last one is GraphX. It's a library for manipulating distributed graph-based data. So graph is actually a set of edges and nodes. So the main abstraction in Spark is RDD, a resilient distributed dataset. Resilient means it's a fault tolerance. If it is lost, if the data is lost, it can be recreated by using history or lineage it maintains. Distributed, like everybody knows, it can be stored across the machines in the cluster. Dataset, it's you can say data means basically data. It's actually meant for dataset. So most of the Spark programming and the large queue return is to perform operation on RDDs. So basically, suppose if you have a data in HDFS, okay, so you load the data from HDFS, so you get a data in the form of RDD. Once you have data in RDD, you can do two kind of operation. One is transformation, another is action. So when you do transformation, you get new RDD. Okay, so when you do action, you get a result or value. Okay, so example, if you see in this example, see in a Spark, whenever you start so Spark, you can you can connect Spark using two ways. One is Spark shell, or you can write a Spark programs using any language like Scala, Python, and Java. So you need to create a context object. When you go via Spark shell, automatically you will get Spark context, which is used to connect the cluster, Spark cluster. Okay, so Spark SC means Spark context dot text file of the file you are loading from either file system or any distributed file system. When you load this, you get a RDD called a text file. Okay, so that is RDD. So once you get a RDD, if you do transformation like filter is one of the transformation, or you can say you can do map or group by. These are some of the transformation. When you do a transformation, you get a new RDD. So you can keep on doing some transformation based on your application logic. You will keep getting new RDDs. So each RDD will maintain history where it has come from. So that is, the history is called a lineage. So in this example, I have 4 RDDs. The last RDD knows where it has come from, so it maintains history. It came from 3rd RDD, like something like that. So next operation is it's called action. Basically, when you do action, you get a result. Okay, you get a result. Or if you want to store your data into again external system, you do action. So either if you want to display your value, you can do action, or also if you want to store your result into any persistent storage, you can do actions. So some of the actions are count. If you do count, you will get the number of lines in the RDD. Okay, so if you want to get the first value from your RDD, then you can use RDD.first. So some of the action examples are count, collect, and save as text file. So text files writes your data, whatever there in the RDD, into text files. So let us compare Apache Spark with MapReduce. So as I mentioned, Apache Spark, okay, it's in-memory data processing. So it doesn't mean that I can use Spark only if my data fits into memory. Even if data is not into memory, you can use Spark. So it writes a result in the disk. Okay, so MapReduce is still disk-based data processing. So whatever data you have, it will read sequentially and do the processing. And Spark gives you programming abstraction via RDD. In terms of MapReduce, everything is a key value pair. So Spark gives when you develop a Spark program, it gives a facility to write less code to do complex things using transformation actions. But if you start writing MapReduce program, you have to do a lot of coding to do simple tasks. Spark provides a good fault tolerance. It means like even if your data is lost, you can build using the lineage. It is maintained by the RDD. Each RDD remembers how it was built from the other data set to rebuild itself. In MapReduce, again it also provides fault tolerance. It is slightly more tolerant. Both gives a fault tolerance. So basically, where I can use Spark is when I can use in iterative application and interactive applications. So if your data has to be reused, suppose you have a set of job, so each job gets out from the previous job. Okay, so Spark is well known for it, because you can hold your data into memory if the data is fits. Okay, and in case of data reuse in MapReduce is not efficient actually. So every job, if you have multiple jobs, every job has to write your output into HDFS. So this is the some of the benchmark done by Databricks. Databricks is a company who provides actually Spark, Apache Spark. So this is a benchmark. So what they done is they taken a set of records and they do sorting actually. So it's under using Hadoop MapReduce, under terabyte of data, and in using 2100 nodes, and 2000 nodes they have done sorting in 72 minutes. Same 100 terabyte of data using Spark, they have done it in 23 minutes using only 206 nodes, that too virtualized nodes. In case of MapReduce they used physical nodes. If you want more details about this benchmarking, you can follow the below links which I mentioned. So where are the use cases Spark fit? So interactive data analysis. If any data engineer or data scientist, if you want to query your data, so they don't want to build the application and then they don't want to see the do some basic calculation. If you want to do it in MapReduce, you have to write your code, MapReduce code. You have to build the jar and you have to run it. So a Spark shell gives you a efficient way to write interactive shell to write your interactive queries or commands to process the data, and real-time querying of data. Okay, so if you have Hadoop, okay, so in Hadoop you have Hive component which give a querying facility over HDFS data. So again it generates a MapReduce job to do the processing. But when you use Spark SQL, it does this processing using this RDDs. So it is very much faster than the Hive queries. Spark SQL queries are very fast. It can give you a result in seconds rather than minutes or hours. Then streaming applications use case, streaming use cases, stream processing use cases, we can use Apache Spark. So we have a component called Apache Spark streaming, which can use for stream processing. So where like fraud detection, if you want to find a credit card fraud detection while during the online transaction, or any log processing which comes as a stream. So we can do some kind of aggregation and analysis and give in alert for it. The last one is so if you have a lot of data coming from some sensor devices, so you can, so if you're coming from multiple sources, if you want to have it in memory and do the processing on those data, so Spark is well fit for that. It is faster to process your data. Thank you very much. If you have any queries and other details, you can log on to the datamaking.com and you can reach us. Thank you very much.